Webb's amazing summary so far. Being the most powerful space telescope isn't easy. People, scientists, engineers, everyone has high expectations. But luckily, the James Webb Telescope didn't disappoint anyone. It was launched on Christmas of 2021. Its first goal was to reach the Lagrange point L2, an equilibrium point in the Sun-Earth system, and to start orbiting around this point. It nailed it, and it didn't have a single moment to chill because people wanted it to be operational as soon as possible. So it carefully started preparing everything: the 18 hexagonal mirror segments, the sunshield, and the instruments. And once ready, it started sending us pictures of the universe as we have never seen it. Looking through Webb's eyes, our understanding of the cosmos is changing and will change forever. This video is a summary of all the magical things Webb showed us so far. Let's start with this one, the Southern Nebula Ring. This is one of the 5 pictures released on July 12, 2022. You can see brownish and reddish colors of gas, and if you look closer, you'll see something bright in the middle. That's a star. It has 6 spikes, but in reality it is a giant ball of gas with solar flares and stuff, but no spikes. We see the spikes because of Webb's mirror shape, which is hexagonal. The thing is, that's not a single star. Using the MIRI mid-infrared instrument camera on board the telescope, astronomers were able to disentangle the two. The second star, shown at the left in red, is in the process to become a fully dense white dwarf star. As it transforms into a white dwarf, the star periodically ejects mass, that is, the material you see all around the ring. The bluer star on the right also helped shape the scene. It actually gave a big contribution to stirring up the ejected material. Webb captured this scene in mid-infrared light, most of which can only be observed from space. Mid-infrared light helps researchers detect objects enshrouded in dust, like the red star. As you can see, this powerful MIRI instrument offers an incredible amount of detail. And if you look close enough, you can realize that very distant galaxies are hiding behind the red clouds. Studying the universe in the infrared is so convenient because the light in the infrared is less absorbed by interstellar clouds. That's why we are able to see such distant objects in the background. This second image is honestly breathtaking. What you're seeing here are the so-called cosmic cliffs. This is actually a young star-forming region in the Carina Nebula. It was captured by the NIRCam on NASA's James Webb Space Telescope, and we have never seen it in such great detail. Apart from its intrinsic beauty, this image teaches us a lot. First of all, this object is 7,600 light-years away, and the cavernous area has been carved from the nebula by the intense radiation and stellar winds from massive, hot young stars located in the center of the bubble above the area shown in the image. Basically, when a star is young, it's also really active, and if there's some gas around it, it's soon blown away. Stars want their own space too. Looking at this star-forming region in the southern constellation Carina, as well as others like it, Webb can see newly forming stars and study the gas and dust that made them. Recently, a team of scientists and music experts have been able to translate this picture to sound. So here we are. We've got a new immersive way to explore some of the first full-color infrared images and data from NASA's James Webb Telescope. You can find the full sound in the link in the description, but be careful. Brighter light in the image is louder. Webb has also shown us Jupiter as we've never seen it before. I mean, look, this is not one of the pictures of Jupiter we're used to. We don't see the usual orange and brownish colors of the gaseous giant. Instead, it looks grayer and almost fluorescent. What's going on? Webb, are you drunk? Well, not really. The thing is, as we've already said, Webb explores the universe in infrared wavelengths. The images come from the NIRCam, a near-infrared camera, which has 3 specialized infrared filters that showcase details of the planet. The famous Great Red Spot appears white in this image, as do other clouds, because they are absorbing and reflecting back a lot of sunlight. Also, there's something really weird going on here. Jupiter has rings? Yeah, indeed. Saturn is not alone, even though Jupiter's rings are way fainter than Saturn's. These rings are mainly made up of dust particles. In the picture, you could also see Amalthea and Adrastea, 2 of Jupiter's moons. But perhaps the most interesting phenomenon to study here is the aurora. There are actually 2 auroras on Jupiter, the southern one and the northern one. Auroras are created when high-energy particles enter a planet's atmosphere near its magnetic poles and collide with atoms of gas. Studying this image helps us to determine how various components of Jupiter's auroras respond to different conditions in the solar wind, a stream of charged particles ejected from the sun. As you can see, the James Webb Space Telescope works really well both in the long and short-distant regimes. Astonishing. But this is not the end. Ladies and gentlemen, fasten your seatbelts because what I'm going to show you is something out of this world, literally. This is the first ever direct image of an exoplanet taken by Webb. You're now witnessing the state-of-the-art of science exploration. Why? Do you have any idea how difficult it is to take a direct image of an exoplanet? Not only is it hard because they are small with respect to stars and because they're far away, it's even harder because they usually orbit around the star, and stars are so much brighter than planets. The planet caught by Webb is called HIP 65426b, and it is more than 10,000 times fainter than its host star in the near-infrared. What you really see in this picture, though, are a series of pictures taken by Webb using different filters. In each filtered image, the planet appears as a slightly differently shaped blob of light, because of the different optical systems used in each case. The view at 3 micrometers is the purple one. The blue one is at 4.44 micrometers, a slightly longer wavelength. The yellow and the red were taken at 11.4 and 15.5 micrometers. Although this is not the first direct image of an exoplanet we have, for example, the Hubble Space Telescope already gave us some. This is a really important step for Webb. This picture is basically screaming, Webb can help us find life on other planets, and we're happy to know that. Speaking of exoplanets, Webb also provided us with the spectrum of WASP 96b. This planet is located at 1,150 light-years from Earth and orbits its star every 3.4 days. What Webb discovered is that this planet has a sodium-rich atmosphere. To be fair, other observations had already confirmed that, but Webb's spectrum is the most detailed of its kind to date. But this isn't the end of the story, because some days later, Webb put its eyes on WASP 39b, and it found something incredible. Previous observations of WASP 39b from other telescopes, like Hubble and Spitzer space telescopes, revealed the presence of water vapor in the planet's atmosphere. But Webb's infrared sensitivity has now confirmed the presence of carbon dioxide on this planet. This is the first real evidence of carbon dioxide in the atmosphere of a planet outside the solar system. Spectroscopy of planets is really important because it gives us some hints on the composition of its atmosphere, the origin of the planet, and how it evolved. In the upcoming months, Webb will make this kind of measurement for a huge number of planets. Keep up the good work, James Webb. Hey, if you're still here, it means you're really enjoying this video. Why don't you subscribe now and press the bell notification? In this enormous image, you can see and admire Stéphane's quintet, discovered by the French astronomer Édouard Stéphane in 1877. At first glance, it's nothing more than a visual group of 5 galaxies, and they seem to lie close to each other. But only 4 of them are truly close together and caught up in a cosmic dance. The 5th and leftmost galaxy, NGC 7320, is not bounded to the system, and it resides 40 million light-years from Earth. The other 4, NGC 7317, NGC 7318A, NGC 7318b, and NGC 7319, are about 290 million light-years away. They are interacting galaxies, and their shapes are weird, This is because tidal forces acting between the four objects are shaping the galaxies and distorting them over millions of years. Sometimes the action of a galaxy on another is so strong that it triggers star formation because the gas from which stars form is perturbed and starts collapsing. As a really nice bonus, Webb revealed a vast sea of thousands of distant background galaxies reminiscent of Hubble's deep fields. Did I say deep fields? Well, just saying, this is one of the most detailed deep fields ever taken. This image is amazing. You have everything that you could ask for. Weird-shaped galaxies, gravitational lensing effect, and God knows what else. Probably there's also dark matter, even if we're not able to see it. But perhaps the most interesting thing here is that every single bright spot here is a galaxy. Of course, some stars happen to be in the field of view as well, but you can recognize them from the spikes. Webb's NIRCam has brought distant galaxies into sharp focus. They have tiny faint structures that have never been seen before, including star clusters and diffuse features. This image actually shows a cluster of galaxies, SMACS 0723, as it appeared 4.6 billion years ago. The combined mass of this galaxy cluster is what acts as a gravitational lens, magnifying even more distant galaxies, including some seen when the universe was less than a billion years old. Webb holds the record for what appears to be the oldest galaxy ever discovered. Look how tiny and cute. Its name is Glass Z13, and it was born just 300 million years after the Big Bang. Last but not least, some days ago, Webb snapped a perfect shot of an Einstein ring. An Einstein ring is created when light from a galaxy or star passes by a massive object en route to the Earth. Due to gravitational lensing, the light is diverted, making it seem to come from different places. If the source, lens, and observer are all in perfect alignment, the light appears as a ring. But where does the light of the ring come from? Those photons belong to a distant galaxy, J0418. It's about 12 billion light-years from Earth, making it one of the oldest galaxies in the universe. The bright blue spot at the center of the ring is another massive galaxy. It warps the space-time, curving J0418's light. The magic trick is then easily performed, and we love it. That's all for this video. What's your favorite Webb discovery so far? Let us know in the comments below. And if you enjoyed the video, don't forget to share it. And I'll see you next time on the channel.